Hi, I'm Kevin Cash. In the next couple of minutes, my two group members, Andy Barone and Alex Logan, and I are going to give you a crisp overview of the OSI model. The OSI model, or Operation System Interconnection Model, consists of 7 layers that set an international standard for network design. The model is very important because it ensures compatibility in regards to network and network systems. We are now going to go into detail about the job and importance of each of the 7 layers. The top layer, or application layer, layer 7, supplies network services to end-user applications. Network services are typically protocols that work with users' data. Protocols that we will typically see are FTP, HTTP, DNS, and DHCP. Basically, the application layer is the layer at which you interface with your computer. Anytime you're using the internet, such as checking your email using MyQ, you are most certainly working in the application layer. The application layer provides data to and obtains data from the presentation layer. The presentation layer, or layer 6, is the layer below the application layer. The presentation layer basically changes the data that is sent from the application layer and the session layer and turns it into something that is readable on your local computer. For example, it may turn photos into JPEGs or GIFs so that your computer can understand it and display it on the user's screen. This layer basically hides the differences between the various types of computer systems that exist in today's world.
Thank you, Kevin. I'm Alex Zaloga, and for the next couple of minutes, I will be discussing the job and importance of the next 2 layers, the sessions and transport layer. Layer 5, or the sessions layer, handles all the sessions for a system. A session is a stream of data flowing between 2 programs and communicates them over a network. The sessions layer initiates sessions, accepts incoming sessions, and opens and closes existing sessions. Layer 5 also keeps track of computer naming conventions, such as calling your computer, for example, home PC, or something along those lines that makes more sense than referring to your PC by its IP or MAC address. Simply, the sessions layer manages connections between machines. Layer 4, or the transport layer, basically reduces outgoing data into smaller parts called packets. After breaking down data into a manageable size, it is sent to the network interface card, or NIC, where it is ready to be sent out. Also, Layer 7 gives the individual packets a sequencing number so the receiving computer can interpret them and read them in a logical order. Simply, the transport layer breaks down data into manageable chunks.
Thank you, Alex. I'm Andy Barone. For the last few minutes, I will explain the last 3 layers of the OSI model. Layer 3, the network layer, controls the operation of the subnet, deciding which physical path the data or packet will take based upon the conditions and priority of service. A subnet is divided into subdivisions of an IP network. The Internet Protocol address, or IP address, is given to each device on the network to distinguish it from the physical address. This IP address is unique to that system on the network. If 2 machines accidentally get the same address, they won't be able to send or receive data. Routing is a large part of this network because it routes the frames among these networks and connects each of the subnets. Routers use the IP address to forward data, which enables data to be transmitted over lines that don't use the Ethernet, like a telephone network. The network layer enables data to be sent from one system to another, unlike Layer 2, the data link layer. The data link layer, which connects hosts within the same network, is the layer that provides error-free transfer of data frames between one node to another over the physical layer, Layer 1. The data link layer provides frame acknowledgement, which detects and recovers from errors that happen in the physical layer by retransmitting non-acknowledged frames, as well as media access management, which determines when the nodes have the right to use the physical layer or medium. The NIC, or Network Interface Card, serves as the interface between the PC and the network. The NIC creates, sends, receives, and reads something called a frame. A frame is a container for data moving across the network. Layer 1, the physical layer, is the method of moving data between computers. It is defined as the hardware connections and turns binary into physical pulses, electrical or light. Repeaters and hubs operate at this layer. This hardware includes the cables, fiber optics, hubs, and even radio waves identified as a physical medium. This layer does not detect what type of data moves through it, but rather just sends the data from one system to another. This layer provides data encoding, an electrical pulse represented by ones and zeros, which you are able to see using a powerful tool called an oscilloscope. The Ethernet incorporates both this layer and the data link layer, as well as other local area networks such as Bluetooth and IEEE, which many people are familiar with now. This concludes our unique and crisp explanation of the 7-layer OSI model. We hope you have a greater understanding of the job and importance of each layer in this model. Thank you and have a great day.